Hello students, today we solve one easiest question. The question is, a ray of light is incident at an angle I on a parallel sided glass slab of thickness D and gets refracted into the slab at an angle R. Draw a ray diagram to show its path as it emerges out of the slab. Hence obtain an expression for the lateral shift of the ray. This question is about a refraction of light through the glass slab. Here we need to draw the ray diagram of refraction of light through the glass slab, and we need to write the expression for the lateral shift of the ray. This is what the ray diagram of light refracted through the glass slab. Consider this rectangular glass slab. Here I is the incident ray. It enters from air medium into glass and gets refracted. So the refracted ray bends towards the normal. That is when light enters from rarer medium to the denser medium. That is, rarer medium is air and denser medium is the glass slab. It bends towards the normal. This is the normal at the point of incidence. So this is the direction of the refracted ray, and we know the angle between the incident ray and the normal is angle of incidence, and angle between the normal and the refracted ray is angle of refraction. And this is the angle of deviation, that is the deviation of the incident ray from its original path due to the refraction. So the angle of deviation is I minus R. Again the refracted ray strikes the another face of the glass slab and gets refracted into the air. We know in the air the speed of the light increases, so the emergent ray is away from the normal. Or we say when light travels from denser to rarer, the light bends away from the normal when it travels denser to rarer. And here you see the direction of the emergent ray and the incident rays are parallel. It's due to the parallel side of the glass slab, or we say the reversibility principle of the light. And the perpendicular distance between the emergent ray and the incident ray is nothing but the lateral shift. Now how do we write the expression for the lateral shift? For that, consider two triangles A and B and NBC. In A and B, we write cos R equal to adjacent side by hypotenuse, that is AN divided by NB. And AN is nothing but the thickness of the slab, that is D divided by NB. From this, we write NB equal to D divided by cos R. In triangle NBC, we find sine of I minus R, that is opposite side by hypotenuse. From this we write NB equal to BC divided by sine of I minus R. When we equate this, we write the lateral shift BC equal to D divided by cos R sine of I minus R. So the lateral shift depends on the incident angle and the thickness of the glass slab. So when the angle of incidence increases, the lateral shift increases, and when the thickness of the slab increases, the lateral shift increases. Next question, under what condition will the shift be minimum? When the angle of incidence is 0, the shift will be minimum, because the lateral shift depends on the angle of incidence. So when the light strikes the slab, normally there will not be any deviation. It refracted back in the same path. In that case, the deviation will be minimum.